Well, hello again, everyone. Today, I'll review with you the 5.4, completing the square. This will be the last lesson before your test on Wednesday and Thursday. But before I get into completing the square, I must review a couple things with you, recall some background knowledge. The first thing that we need to do very well when we complete the square is we have to work with square roots. So let's recall properties of square roots. Okay, we say that the square root of a times b is equal to the square root of a times the square root of b. And that will be very important when we have to simplify radicals or square roots. So for example, they gave us that problem, the square root of 12. I can simplify that into two components. That's equal to the square root of 4 times the square root of 3. Now, why would I do that? Because what I'm looking for, when I see 12, I'm looking for factors of 12 that are perfect square numbers. And when I say perfect square numbers, I mean these numbers like 1 is a perfect square number because 1 times 1 is 1. 4 is a perfect square number because 2 times 2 is 4. 9 is a perfect square number because 3 times 3 is 9. So I'm looking for perfect square numbers that are factors of what's underneath the radical. And so 4 is a perfect square number, and it's a factor of 4. Now the reason we do that is because we know the square root of 4, and that's equal to 2. So when I simplify root 12, I get 2 root 3. Again, you recall from geometry, I'm sure your geometry teacher said, give me an exact answer. So no decimals, but an exact answer that would involve a radical. And likewise, when you do these problems for homework or class, or even on a test, okay, and when I say we, I mean Algebra 2 teachers and above, we like to see exact answers, no longer decimals, okay? You need to know how to simplify radicals. Okay, so that's the one thing. And then the other thing is we say this property here, that the square root of a over b is just equal to the square root of a over the square root of b. Okay, so they gave us an example there, square root of 25 over 16. That's equal to the square root of 25 over the square root of 16, which is just 5 over 4. Okay, so we'll be using these two properties a lot when we complete the square. But it's important to, when we simplify radicals, to remember your perfect square numbers. Okay, you have to remember your perfect square numbers. All right, so that's the required knowledge in working with completing the square. We will be simplifying radicals. All right, so our objective today is solve quadratic equations by completing the square. Okay. Again, another thing we have to remember is the square root property. And so what does the square root property says? It says that if we're solving for x squared, we have to consider two cases, a positive and a minus case. So for example, if I said x squared is equal to 4, there's two possibilities for that. Either x is equal to negative 2, okay, because negative 2 squared is equal to 4, or x is equal to 2, because 2 squared is equal to 4. So anytime we solve a square root, we have to consider both the positive and the negative case. The only time that never happens when we only have one case is when x squared is equal to 0. Okay? That's the only time we will never have two possible answers. All right, so the way we solve for square roots, we just take the square root of both sides to get the answer. So here they said that x squared is equal to 15. So we just take we undo squaring, which is taking the square root. We take the square root of both sides, but we have to remember to write our plus and minus because we have two possibilities. We have two possibilities. A positive root 15 and a negative root 15. Now notice here I cannot simplify root 15 because there are no perfect square factors of 15. But let's say here if I had x squared is equal to 27. And again, to solve for that, I undo squaring, so the square root, and that would be x squared. And that would be x squared is equal to plus or minus root 27. But here I'd have to recognize that the largest perfect square factor of 27 is 9. If I go back up here, is 9. 9 is a perfect square perfect square number. Okay, so I forgot. I solved for x squared. X is equal to plus or minus root 27. So this would be x is equal to plus or minus root 9 times root 3. Well, we know that root 9 is 3, so the answer would be x is equal to plus or minus 3 root 3. Okay, so let's look at some examples they gave us. They said solve the equation. 4x squared plus 11 equals 59. We subtract 11, we get 4x squared is equal to 48. We divide by 4, we get x squared is equal to 12. We take the square root of both sides, we get x is equal to plus or minus 12. I want to use red. Okay, I always like to. Okay, so when we take the square root, we took the square root of both sides, and we got x is equal to plus or minus root 12. And again, plus or minus root 12. Well, the largest perfect square number factor of 12 is 4, so this would be plus or minus root 4 times root 3, which will be plus or minus 2 root 3, which is the answer they had. Let's look at another example here. Solve the equation 4x squared minus 20 equals 5. So we add 20 to both sides. And then we divide by 4, and we get x squared is equal to 25 over 4. And then we undo squaring, so we have x is equal to plus or minus root 25 over plus or minus root 4. And so we have x is equal to plus or minus 5 halves. Root 25 is 5, and root 4 is 2. And again, we're using this property here that I mentioned. Right there. The square root of a over b is equal to the square root of a over the square root of b. All right, let's continue on. Now, one thing in completing the square, it's not just one thing, it is the most important thing, and I talked about this very briefly, and it was mentioned very briefly in section 5.3, is what we call a trinomial. Okay, a perfect square trinomial in particular. And we say it's a perfect square because here, I'll show you why. I always like using a square. Okay, we know a square has equal sides, right? And so if I take a look at this, if I have that's A, and this is B, and that's B, okay, and let's say this is positive. So if I find the area of each of those four squares, a times a is a squared, a times b is ab, a times b or b times a is ab, and then b times b is b squared. So what we have, the area of that square then we would say is equal to a squared plus 2ab plus b squared. Okay, so we call quadratics that are in this form a squared plus 2ab plus b squared a perfect square trinomial because the sides are the same. Now the other way I could write that, I could write it so it would be a plus b is one side times a plus b is the other side, or it's just a plus b squared. Okay. Perfect square trinomials, you'll see in just a second, is the only way we can solve quadratics when we can't factor. Well, it's not the only way. We can use a quadratic formula, but perfect square trinomials are important when we complete the square. And you'll see what I mean. So here, we'll be working with perfect square trinomials. So for example, they gave us some examples here. X minus 5 squared, which is just x minus 5 times x minus 5. It's a perfect square trinomial. Again, I can represent that as, so this would be x, and that's x, and that would be minus 5 and minus 5, and so I'd have x squared minus 5x and 25, which would give me x squared minus 10x plus 25. Perfect square trinomial. 3x plus 5. Okay, if we follow that, it would be 9x squared plus 30x plus 25. Again, this side would be 3x plus 5. That would be represented this way. So, okay, as a square. So here I have 3x. Here I have 3x. Here I have 5. Here I have 5. This would be 9x squared. 3x times 5 is 15x. 3x times 5 is 15x. And 5 times 5 is 25. And again, combine our like terms, 9x squared plus 30x plus 25. And then again, x squared minus 18 plus 81, that would be a perfect square trinomial. If you factor that, factors of 81 that add up to negative 18, that would be x minus 9 times x minus 9. It's a perfect square trinomial. Okay. And then if you did the crisscross method for 16x squared plus 24x plus 9, you would get 4x plus 3 if you factor times 4x plus 3. Okay, so perfect square trinomials are essential when we complete the square. And you'll see what I mean. All right, so now you may ask the question, okay, Mr. Winston, how does perfect square trinomials help us solve quadratic equations? Okay, particularly when we can't factor. Well, hold on, we'll see. If a quadratic expression of the form x squared plus bx cannot model a square, you can add a term to form a perfect square trinomial. This is called completing the square. Okay, so here they give you an example, but I always like to tell students this. So this is what we do. Okay, so here they give us an example: x squared plus 6x. How do we form a perfect square trinomial? The important thing, you only work with the linear and quadratic term. The linear and quadratic term. Okay, so we're only working with, well, if I had to list a standard form, ax squared plus bx plus c. When we complete the square, I'm going to say this again, when we complete the square, I'm going to say it again, when we complete the square, we only work with the quadratic and linear term, only when we complete the square. I'll say it again, only the quadratic and linear term. So here they give us an example, x squared plus 6x. So this is generally what we do, okay? What we do, okay, and visually I'll go through completing the square, so I'll just draw a square. Okay. Now, this x squared I'll represent as x times x. That's my x squared. That's my x squared. It looks like x2. And then what we do, we take the b term right here. We take the b term, that's 6, and we divide it by 2. So 6 divided by 2 equals 3. And then we put that there, and we put that there. Now notice here we have a perfect square because we have the sides are the same, x plus 3 and x plus 3. But now x times 3 is 3x, and then 3 times x is 3x. But now when we complete the square, notice here we'll take that 3 times 3 and we'll get 9. Okay, we get 9. So that's what this property is telling us. To complete the square, we take the b term, and in this example it was 6, and we divide it by 2. And then we square it. Okay, so this was x, so we had x squared plus 6x plus 6 divided by 2 squared, and that just gave us x squared plus 6x. 6 divided by 2 is 3, and 3 squared is 9. Okay, and so here, so we have a perfect square trinomial. The side is x plus 3 times x plus 3, or x plus 3 squared. Okay, so we have a perfect square trinomial. So we always take the b term, we divide it by 2, and we square it, and then we add it to the quadratic and linear term. The quadratic and linear term. Again, the quadratic and linear term. We take b divided by 2 and add it, square it, and then add it to the quadratic and linear term. And so let's go through some examples, and you'll see how this helps us to solve quadratic equations. So here we have x squared minus 14x. So again, visually, I always like to show completing a square. Some students have found this very helpful in the past. Okay, so I draw my square. So I have the x squared. So here's my x and my x. Now I'll take negative 14. So I'll take negative 14 and I'll divide that by 2, and that will give me negative 7. So that's my negative 7, and there's my negative 7. Now I'll complete the square of x times x is x squared, x times negative 7 is negative 7x, negative 7 times x is negative 7x, and then negative 7 times negative 7 is 49. Now notice here that, okay, I have x squared minus 7x. It looks like a 2. So our x squared minus 14x. Okay, and that's what I started with. X squared minus 14x. All of that there. That's what I had. X squared minus 14x. But when I completed the square, I added 9. So I added 9. I took that there. So again, what did we do? We took x squared minus 14x, and we took minus 14, we divided it by 2, and we squared it. And then we got x squared minus 14x plus 49. And you can visually see that that is a perfect square whose sides are x minus 7 times x minus 7. Or just x minus 7 squared. It's a perfect square trinomial. So we're forming perfect square trinomials like forming a perfect union. And you will see very shortly why that's important, okay, in solving quadratic equations. So again, just go through some more examples. Here we have x squared plus 9x. We have x squared plus 9x. So again, I'll visually illustrate what's going on. So here, so I have my x and x. That will give me my x squared. I take 9, divide that by 2, and no decimals. No decimals here. That will be 9 halves. 9 halves. Okay, x times 9 halves is 9 halves x. And 9 halves times x is 9 halves x. And 9 halves plus 9 halves will give you 18 halves, which will give you 9, which is what we started with. So this is 9 half x. So all of this here. Oops, what happened to my x squared? Where'd it go? X times x is x squared. X times 9 half is 9 halves x. And 9 halves times x is 9 halves x. So that's what I started with. Oops, come on. Oh, it's driving me crazy. So this is x squared. So that's what I started with. X squared plus 9x. Add up the 9 half x twice and you get x squared plus 9x. But when I completed the square, what did I add here? Well, 9 halves times 9 halves is 81 fourths. 9 times 9 is 81, and 2 times 2 is 4. So I added 81 fourths. Now I have a perfect square. Whose sides are x? Whose sides are x plus 9 halves squared? X plus 9 halves times x plus 9 halves. Or that's just equal to x plus 9 halves squared. Alright, so yeah, x squared plus 9x plus 81 over 4 is when we complete the square. And then one more. Here we have x squared plus 4x. So again, I'll visually draw what's going on. Complete the square. Okay, so I have x times x, x and x. That gives me my x squared. I'll take 4 divided by 2. That will be 2. There will go my 2 and 2. X times 2 is 2x. 2 times x is 2x. So that gets me then x squared plus 4x. That's what I started with. But then what did I add? Okay, well, I added 4. Okay, and you see, so I have x squared plus 4x plus 4, as you see there. But that's just x plus 2 times x plus 2. The sides are x plus 2 times x plus 2, so that's going to be x plus 2 times x plus 2, and that's just equal to x plus 2 squared. Perfect square trinomial. All right, so again, you're probably asking, okay, Mr. Winston, how does perfect square trinomials help us solve quadratic equations? Okay, now we come to the moment of truth. You can complete the square to solve quadratic equations. Solving quadratic equations, ax squared plus bx plus c equals 0. Here you collect the variables on one side of the equation and the constants on the other. Otherwise, you have ax squared plus bx, and then over here you have c. As needed, divide both sides by a to make the coefficients of the x term 1, although we'll do something else because you can't always divide every term by the same number. It's better to try another method or do another method, which I'll show you. And then you'll complete the square by adding b over 2 squared to both sides of the equation. Then you'll factor the variable expression as a perfect square. And what they mean by that is that, okay, so when I completed the square here, I got x squared plus 4x plus 4, but I'll just write that x plus 2 squared. I'll write it as its factors. Okay, I won't write it like they did there, x squared plus 4x plus 4. I'll rewrite it. I'll write it as is the product of its factors, x plus 2 squared. Then we'll take the square root of both sides, and then we'll solve for the values of the variable. Okay, so let's go through some examples here. So let's say here I have x squared equals, so they give us x squared equals 12x minus 20. So again, we need to get the quadratic term and linear term on the left. So I'll subtract 12x. X squared minus 12x equals negative 20. Okay, so now what we do, follow the steps here. We have to complete the square. So again, I like to do this visually. Okay, so here, because it always helps students to see completing the square. So I need to take that x term, okay, x and x is x squared, and then we take that negative 12 and we divide it by 2 like they did there. So negative 12 divided by 2 is negative 6. So here's my negative 6 and negative 6, and then x times negative 6 is negative 6x. Negative 6 times x is negative 6x. But when we complete the square, negative 6 times a negative 6 will give me a 36. But now notice what we have. We have x squared minus 12x plus 36. Well, x squared minus 12x is what we started with, and we still have that when we add that up. But now we added 36 to both sides. We completed the square. Okay, so we started with x squared minus 12x. We added 36 when we completed the square, but we have to balance the equation. If we add 36 to the left, we have to add it to the right. But now x squared minus 12x plus 36, we'll write that as a product of its factors, which is just x minus 6 squared. X minus 6 squared equals 16. And now you'll see we're able to solve this. So what do? We take the square root of both sides. Okay, we'll get rid of that squaring. And then we'll have x minus 6 equals plus or minus 4. And then we'll add 6. X equals 6 plus or minus 4. And so we'll have two answers. X is equal to 6 plus 4, or x is equal to 6 minus 4. And we'll have 10, and we'll have 2. Now, we could have just as well had factored that one. Okay, we could have factored that one there, because we started, so here I'll show you. We had x squared minus 12x equals negative 20. If I bring the 20 over, it becomes positive. Set that equal to 0. Again, I'm looking up there. X squared minus 12x equals negative 20. And if I add 20 to both sides, I get x squared minus 12x plus 20 equals 0. And factors of a positive 20 that add up to negative 12, well, that would be x minus 10 and x minus 2 and equals 0. And so what we would get is x is equal to 10 when we solve for x, and x is equal to 2, which is what we got when we completed the square. We got the same answer. Okay. Life is easy when you can factor, but most times you can't. So we complete the square. Let's look at the next example. So here we have x squared plus 6x. Okay, we're going to equals 15. The quadratic term and linear term is on the left. The constant is on the right. Again, I'll draw my square. Okay, so the x squared, that's x and x. We take 6 divided by 2, that equals 3. So 3 and 3, and then we'll complete the square. And 3 times 3 is 9. So I started with x squared plus 6x, but when I complete the square, I added 9. So what do I have? I have x squared plus 6x. That's what I started with. But I added 9. Now I have to add 9 to the other side. I have to balance that equation. This is a perfect square trinomial whose sides are x plus 3 squared. You can look at the picture there. Okay, x plus 3 squared, x plus 3 squared, and this is equal to 24. Now I'll take the square root of both sides, and then this will give me x plus 3 equals plus or minus root 24. Okay, I'll simplify root 24. The largest perfect square factor of 24 is what? 4, right? Perfect square factor, perfect square number. The largest perfect square factor of 24 is 4. So this would be x plus 3 equals plus or minus root 4 times root 6, which is just plus or minus 2 root 6. And finally, subtract 3, get x is equal to negative 3 plus or minus 2 root 6. All right, and what I suggest as you guys are doing these problems here, you can always check these on Schoology. I mean, not Schoology, but on Desmos. So if I had the equation, if I wrote it, so we started with x squared plus 6x equals 15. If I write that, if I add, let's just say we want to find the zeros, right? Because that's what we're really doing. So if I subtract 15 from both sides, I would have x squared plus 6x minus 15 equals 0. Well, we couldn't factor that. There's no factors of negative 15 that add up to 6. But what we could do, we could go out to Desmos, and then we could verify the zeros on Desmos against the zeros we got there. Okay. Well, you'd have to convert root 6 to a decimal and multiply by 2. Okay, but you'd have two answers. You'd have negative 3. You'd have negative 3 plus 2 root 6, whatever that evaluates to, and then you'd have negative 3 minus 2 root 6. On the second part, I'll show you actually doing that using Desmos, so it's a good way to check your work. All right, so because this lesson is kind of long, I'll show you an example of doing that. So let's look at a couple more examples here. So here, x squared minus 2 is equal to 9x. So again, we want the quadratic term and linear term on the left. So I need to subtract 9x. So I'll have, if I subtract 9x, and then I need to add 2 to both sides. So then I'll move the 2 over. So this will equal that. So I move the 2 there, and then the 9x over there. So x squared minus 9x is equal to 2. That's what we started with. Okay, that's what we have. And then we complete the square. Again, we're just completing the square on a quadratic and linear term. All right, so I have x and x, and then I have negative 9 divided by 2. No decimals, please. So that's just negative 9 halves. Negative 9 halves. Complete the square. X times x is x squared. X times negative, okay, and then x times negative 9 halves will be negative 9 halves x. And then 9 halves times 9 halves is 81 fourths. So when I completed the square, I'm adding 81 fourths. But I have a perfect square trinomial whose sides are x minus 9 halves squared. So let's see here. So we had x squared. We started with x squared plus 9x. When we completed the square, we added 81 fourths. But on the other side, what did we have? We had 2. We have to add 81 fourths again, because that's how much we added. We have to balance the equation. Okay, but that's a perfect square trinomial whose sides are x minus 9 halves squared. And then 2 plus 81 fourths, well, I know, so that's like 2 over 1. I need to multiply 2 over 1 by 4 to get, remember you can only add and subtract fractions when the denominator is the same. So I need to multiply that by 4 and that by 4. And I get 8 fourths plus 81 fourths. And that's equal to 89 fourths. And again, they worked the problem out for you. 89 fourths. Now you see, all I have to do is take the square root of both sides. Okay, and now I have x minus 9 halves equals plus or minus root 89 over 4. Okay, which is just plus or minus root 89 over root 4. And there's no perfect square factor of 89, so that's just plus or minus root 89 over 2. So I have x minus 9 halves equals plus or minus root 89 over 2. And then finally, I'll add 9 halves. Okay, plus or minus root 89 over 2. In which I can write, okay, same denominator. Let me, my board likes to move on me. Okay, in which I can write x is equal to 9 plus or minus root 89 over 2. Okay, so that's it for that first part of completing the square. And then the second part, we'll take a look at what happens when a is not equal to 1. So that's a little more work. So we'll have part 2.